Yep, so my name's Rhiana. Yeah, as Alyssa said, who was on before, I'm from Blake. We make reading eggs for you parents up there. Yep, so any bug reports, like feel free to, tell them to me at the end and I can go make some tickets for them.
You're supposed to say
Yeah,
throw them in the garbage, right?
I'll definitely make tickets for them, yeah. So a lot of our apps are on Ruby on Rails backend, and then we use Ember, which is a JavaScript framework from the front to end. I kind of do a bit of both, and then we're kind of branching out. So any new stuff is getting built in Elixir. So they've very politely asked us all to learn Elixir if we are interested in it. And so, yeah, me and Alistair have been learning a bit of Elixir, which has been fun. Yeah, so we have been doing some ones on this one. This is the Exercism track. It has a bunch of different Elixir, kind of like, I wouldn't say academic, but it's kind of like academic little exercises. So, do your song counting down from 100. There's a D&D sheet, which speaks to me, but I haven't done it yet. RNA transcription, that sort of thing. So there's lots of like little exercises. We've been finding they take about an hour or so to get through the easy ones. So might take a bit longer, but they don't take too long, which is quite good. Yeah, you do have to log in to see them, but it's free, so all good. All right, yeah, so we did Armstrong numbers the other day. Just so before I get into that one, I just wanted to show a couple of other kind of resources and bits and pieces that I had to learn because I'm very new to Elixir and I had no idea what anything is or what anything is still. I'm definitely going to get terminology wrong, so feel free to put up a hand and correct me if I use the word method, which I'm pretty sure I'm not allowed to say here. But yeah, let me know because I'm still getting my head around the terminology and how things are working. Yep, so one of the things is here. So on the command line, there's a couple of cool things that we can do. So one is IEX, and that gives you your REPL loop. So if you find anything you want to try out, you can go in here and you can test it out here, which is quite cool. I do that quite a bit because I have no idea how to do any of the syntax yet. And then the other one here that I'll be using today is mix. So like if you use Rails or something, like using bundle and Rails and all that sort of stuff, this one uses mix. And if you just write mix test, it does all your tests for you, which is pretty cool. So they're the main two kind of command liney ones. Thankfully, my laptop already had Elixir installed. So that's good. I don't know what version I'm on or how to install it, so don't ask me about that. But yeah, they're the main kind of command line tools I'm going to be using for that. All the ones that we've done so far, they've all been very test-driven development, so they come with a bunch of tests, which you then have to work on and then gradually get them all passing. So it's the mixed tests and the IEX to test stuff out. The last one, which I'll post a link to this one in the chat, this is where we've been getting all our documentation for learning. Hexdocs.pm Elixir kernel. I'll see if I can find chat to put that in soon because I seem to have lost it just now. Yeah, so we've been finding this is really good. It's got lots of, like I know nothing about Elixir, but I've been finding I've been able to actually figure out some things from here. Just kind of been looking at it, so integer, and you can kind of guess what they are from looking at them, and then they have like lots of like little examples which you can then go through. You can put them on your IEX kind of line, which is kind of cool. This is something that was pretty new to me. In Rubyland, all our methods in Rubyland, you don't have to put any of these names in front of them. But these ones you do. I think these names are the modules. So you got your module and then dot the function that belongs to that module. I think so. It's a little bit more verbose than I'm used to, but I'm kind of getting used to it. I think it does make it easier to kind of look up what the function actually does, and it gives you a bit of extra context. And I think it would make it a bit easier for kind of searching and figuring out what it is and where it belongs, and give you a bit of information for what it's going to do. And yeah, makes it so you don't accidentally call something a name you're not supposed to. So yeah, you can put your code just here on here. Oh no, it's not letting me do that, but that's okay. But if it was, it must require integer. How do I do that? Require integer.
The perils of live coding, right?
There we go, require integer. I didn't know how to do that, and it worked itself out. Yeah, and there we go. Yeah, so you can just kind of put it in your command line and you can test it all out, which is pretty cool. The other thing that I found interesting with these docs and with Elixir in general is that you can have functions that have the same name, and that's okay. And it seems to actually be encouraged, which I find really confusing compared to all other languages that I've ever seen. And it will kind of figure out which one to do based on the arguments that you give it. So I'll try and find one. I found one just before that was a good, yeah, there were kind of some ones in the string ones, I think. And they had ones in there, and I can't find it now. But they had, it kind of tells you how many arguments it's expecting, and then it will do that specific function depending on how many arguments you're giving it. And I think it can even do it depending on what type of kind of argument you're putting in. If you're putting in an array versus a string versus an integer, you can have them all in the same namespace, and then Elixir figures out, okay, it's giving me a string, I'm going to do the one that's expecting a string, which is pretty cool. It means you don't have to think of, you know, one name and then put for strings or for arrays or whatever, or have like one method or function with like a million case statements or if statements in. You can just kind of have multiple functions with the same name and, you know, structure it in a way that it kind of figures out what to do, which I think is pretty interesting. All right, so I'll just get out of here and go over the example. Yeah, so this example is pretty maths. I've also been learning Lisp at the same time because, I don't know. So yeah, very maths heavy kind of time. So this maths problem, so basically we're just going to get the code to do the maths for us. So an Armstrong number is where you get the number of digits in the number. So if it's, say, 123, it's got 3 digits. You then chunk it up into the three individual numbers, and you put them all to that length. So for this one, and then you plus them all together. So 123 would be 1 to the power of 3 plus 2 to the power of 3 plus 3 to the power of 3. You figure out what that is, I think 14, and then you see if it equals the number that you started with, 123. If it does, it's an Armstrong number. If it doesn't, it's not an Armstrong number. So that is what we were trying to do in Elixir. So here, when you download it, it comes with this all written. So it has a lot of different tests. Basically, these tests are just, is this an Armstrong number? Is this an Armstrong number? And they get harder and harder. So first of all, you try and get it to do like single kind of digits, and then you can kind of build up from there. This is what we came up with eventually. At the start, it was very Ruby or very JavaScript. So I had lots and lots of random named variables that I had to keep track of. And then I was kind of dot chaining them together. But eventually, I think we refactored into something that may resemble Elixir. So I'll just go through kind of what we did. So first of all, the way that we get the number is an integer. We don't really want it to be an integer because we want to do it on every single individual number in the integer. So the first thing that we did was we decided to use this integer digits function, which takes the number and it chunks it up into an array full of digits. So we can look up this one here. There's also undigits, there you go. Yep, so then it has in here, so it takes the digits like 1, 2, 3 and it puts it into an array of 1, 2, 3, because then we want to go over it and do things to all the numbers. Then what we did, we found the length of the array, because that's going to give us our exponents. So that's what everything's going to be to the power of. Length I didn't need to put a thing in front of it. I think it's a kernel one, but I'm not sure. But I didn't have to for this one for some reason. So yeah, so I find the length of the digits, find the length of the array, and those are the two things that we need. Then we tried to find the answer, so then we can compare it to the number. So we took the digits array, we then mapped it and put every digit to the, we use this one math.power, so you put in your base and your exponent and it figures out the number, so 2 to the power of 3. Yeah, that would be 2, that would be 3. And then we plus them all together with sum, and then we compared them. So it turned out pretty nice in the end. This little thingy here was quite cool, and this prevented this little kind of arrow thingy. I'm not 100% sure what this does, but it prevented me having to come up with a lot of variable names, so I quite like it. But I think what it does is it takes this one here and it kind of channels it in and channels it in. I'm not quite sure if it's the same as just kind of dot chaining everything. I think it might be a little bit smarter than that, is the impression I have. Yeah, but that's quite cool. So it takes this one in, it goes through, it maps it all in, and then you get your, so map will return, I think it returns an array with the new numbers in it that have got the exponent applied to them, and then it sums them all together. It gives you back an integer, and then you just compare it with your double equals, and you get a true false. Before we figured out that the math.power exists, I made my own one, which is pretty, yeah, which was kind of fun. I don't know. What I did to make my own power function was that I got a list, which I think is like an array or is an array, and then I filled it full of numbers depending on the base and the exponent. So if it's 2 to the power of 3, this turned into an array of 2, 2, 2, so 3 2s, and then I times them all together to make a power function, because I didn't know that math.power existed. But then we found that later and replaced that. But I quite like this, so I left it in. Yeah. And so then as you go, you can kind of they start off with these pending tag ones, so that you don't get too overwhelmed with like 50 failing tests at the start. But then, yeah, then eventually we're able to, run it and get it all to pass. I did find the test feedback was quite good. So for example, if I just put this instead as just like, I don't need to do that, everything to the power of, 3 or something, it's going to come back as wrong. But I found it quite good because it tells you kind of, not too much in this one, it tells you kind of what it was expecting. If it was expecting something truthy and it got false instead. There was other ones where we might have been expecting a particular number or a particular string, and it told you exactly. It's like, we expected this string, we got exactly this string. So I have been finding that they have been giving quite good kind of feedback in the tests as well, which has been very helpful, because it's been, takes a little while to get there when you're not used to it. So let's put that back. So so after we did that one, that one's all working now. We've then been going through and doing maybe one a week, one every 2 weeks, and looking at a few other ones and learning a few other bits and pieces, and just starting to get my head around all the new terminology and bits and pieces. But it's been quite interesting, and I look forward to doing a proper project in the future. Thanks.
Awesome.
Thanks, Rhiana.
No worries.
Has anyone got any questions for Rhiana?
Yeah, do you happen to know, like in the real world, what an Armstrong number would be used for? Like, obviously it looks like it was potentially created to bend software developers' heads. But is there,
as far as I can tell, most of these are for that. We can have a look. I'm not 100% sure if it has a real life application. a lot of these ones.
Narcissistic. Okay.
Why are they called a narcissistic number? I don't know. Yeah, it's a lot of maths there. Yeah, I think it's just so you can practice playing around with numbers and arrays and bits and pieces. There are kind of some ones that are quite useful. There's one for Roman numerals. There's one for RNA, which I quite like. Yeah, but most of them are pretty arbitrary, just to kind of get your head around bits and pieces of the language.
Something the interesting thing with the Armstrong numbers is that they only are an Armstrong number if you represent them in decimal, right? Because it depends on the number of digits.
Decimal, so you mean an integer rather than a float? Or?
No, I mean like 0 to 9. So each digit is 0 to 9.
Mm-hmm.
So that would depend. That affects how many characters
base
there are.
10.
Yeah.
Yeah, this is only base 10. I'm not sure if you could do it for base anything else. Yeah.
I like how they're classified as narcissistic numbers. I find that pretty funny.
I guess it does love itself. It's, yeah.
Challenge for the next Elixir meetup is to get your own Wikipedia page about a special note and a special number named after yourself. for maths challenges in Elixir.
Mm-hmm. Yep. Yeah, I'm pretty sure it's just only function. There might be something in maths, or it just could just be an oddity that they came across one day and decided to name it.
I just want to also say your implementation is very, very clean.
Oh, thank you.
It's really good.
Yes,
Yeah,
it didn't start off this clean, so yep. So if you're also new, please don't be intimidated. This took a lot of hand holding and a lot of iterations. So yep.
I can't think. There's no obvious cleaner way that comes to mind than that. it's pretty
hey.
good. Yeah.
Oh, that's good.
I can't think how I would do it simpler. But anyway,
well, and it's highly readable, right? So even if you didn't know what an Armstrong number was, you could read this and kind of very quickly come to that.
Yeah, I'm a big believer in making code as readable as possible. The future me who has to look at it and present it and remember what it is.
Yeah, definitely. Yeah, it's your future self that you're really going to protect.
Yeah, usually, yeah.
As it is, that solution only has one optimization, I think, which is fusing enum map and enum sum into the enum dot reduce, so that you only pass through the list once, but that probably makes it less readable.
I find reduce is a little challenging to read, yeah. I liked it this way because it was exactly what it was doing in the maths. But yeah, might give it a go, see if I can make it any lower. Otherwise, I thought maybe I could do kind of this, but I don't know if that would help. But then, I got to get the links. Yeah, still need the. That's why I didn't do that. I thought there was a reason. Yeah, you still got to get this exponent.
Did you end up submitting the solution to Exercism's website?
No, I wasn't really sure how to do that, but maybe. Oh, yeah, there is a way to do that. Yeah, maybe I will.
Yeah, it's cool because it gives you it basically enables you to keep a tab of all of the iterations, because you can submit every iteration there and it sort of keeps all the versions there for you.
Okay, cool.
And then it gives you access to everyone else's solutions who posted them there. So it's a cool thing to learn from, I found, at least.
Nice. I'll have to give that a go.
Well, the other thing I was going to ask you, Rhiana, and this is something that I'm finding as a challenge on my Elixir journey, because I'm fairly new to it myself, is just learning to think functional as opposed to what I'm used to, right? Like I'm used to thinking in, while loops, if blocks, all that jazz, and like the imperative style. And this is not like that at all. Are you finding that difficult to conceptualize the problem in a functional term as opposed to how you would normally tackle it in, say, Ruby?
I think the thing that did my head in the most that I still can't figure out is that that you can't kind of modify things. You have to kind of make a new thing to modify. So like string concatenation, which I'm pretty sure string concatenation is like 90% of everything. You can't do that because you have to like make a new thing and then kind of add the strings together to it. You can't just kind of keep adding and throwing stuff at it. So that's been quite challenging. Yeah,
immutability's been challenging for me as well. I think that was where the pipe operator was born.
Yeah, so that one's challenging. As I said, I've been learning Lisp and the structure and interpretation of computer programming at the same time. So I find that's kind of helpful because that book kind of goes into a lot of kind of the theory and stuff behind it, and the maths is also a lot harder, making this math look a bit nicer. Yeah, so in that one, I'm trying to remember which one we actually learnt about, like data pairs and things, because I hadn't really learnt about them before, and so some of the ones we were doing were on data pairs, which is quite interesting. I'm trying to remember which one it was. Maybe Alistair remembers which one we did that in.
Was the data pairs the links list stuff? Is that what you mean?
No. Maybe.
I think maybe it was. We had to do some kind of. I think it was the grip one maybe, or the strain one. Yeah.
No, we haven't finished grip yet. Yeah, strain one. Yeah, where we had like these data pair things. So this is doing my head in as well.
Yeah, so that looks like it's leading you into recursion, which absolutely.
Yeah, we
my
did some
head as well.
recursion. Oh yeah. I've been trying to challenge myself and learn recursion at the moment, but man, it does my head in. Just like, and then you have it, and like in this one, you kind of got to just keep passing itself to itself until it runs out of things, and then when it runs out of things, it then does like this one, which is like the Terminator kind of one. And then I have one down here, which is kind of doing the same thing, because this is make our own filter one, but like the opposite, and it gets rid of it, and it does everything but kind of the opposite. And it's still doing my head in this one. It's not the most readable, but it's just so I could learn, kind of some of the more, functional programming concepts. Oh.
Once you learn recursion, you'll get it.
Yeah, one day. And then I just have to learn recursion, and then,